Okay, welcome everybody. Thank you all for coming along today. We have Robin Long joining us from University of Lancaster, and he's here to talk about how to make our lives less stressful with kids. Over to you.
Oh, thank you. Quick bit actually on my background, because one of the hardest things I find with teaching or explaining anything software or computing related to people is your use of it tends to heavily depend on what your research area is and what your background is. So most of the advice I got here is what I've picked up from helping people over the years, but my background is not computer science, it's not maths and stats, it's particle physics. I did that for my PhD and then did administered a huge particle physics computing cluster for too many years, and then progressed to my current role as a research software engineer, supporting people on using computational resources and writing software. So, yeah. So some of the examples might not make sense to you all. Some of them will, so I'm hoping for a balance. But if it doesn't make sense, ask questions. And also, I have a tendency to get very nervous and speed up. So if I get to the point where you can't understand me, just tell me, and I'll try and slow down again. Okay, so Git and version control. There we go. Yeah. Okay. So I'm going to start off with a few examples of problems that can occur during research, analysis, writing things, more geared towards research, where Git and version control can be useful. So the standard research workflow, heavily simplified, is obtain data, analyze it, write up, publish, and then get comments back from the reviewers and have to make modifications. And problems can occur at every stage of this. Some of them worse than others. Most of the time, it's just chaos. Where did I put the data? Where did I get it? Whereas, so just a quick look at them. So problems with the data: multi-step process, acquire, combine the data, integrate it, reduce. And often I end up finding people where they're stuck of, where did I get the data from? Have I modified this data? What state's it in? And then you move to the analysis. This is the more common one I find. The code worked on Friday. Now that one is, that seems to be a universal one. Something worked on Friday. You made the mistake of changing it after lunch on Friday. It doesn't work on Monday. Well, you know, what did you change? Why is it not working anymore? How can you undo that problem? Or the analysis code, you've got nice results, but was it done with the code on your machine or the code on the postdoc's machine? Or the code on one of the PhD students' machine? Which one? You know, and sometimes you change the way the code works and you're just commenting out the old one so you don't forget how it did it because you moved it to a fancy new faster method that you don't really understand, so you keep the old one there to make sure you actually know what's going on. Or people are afraid to change their analysis because what if it breaks it and you're stuck with the Friday problem again? And then there's the write-up, you know. Suddenly you realize the code doesn't do what you thought it did. So why did you make that change? And you've got to write about this in the paper now, but you've got no record of why you changed the code. Or is it even the code that was used to produce the plots? Can you actually remember that? Are you sure? And publishing, what's the best way to share the code? Email it out to people as they want it, just put a tar file on a website somewhere. And is your code in a way that can be cited easily? And then we get the reviewer, and it's almost the same problems all over again. You know, the editors want to see the plots in a different way, but the code's moved on since then. So can you actually easily recreate those plots again? You know, is it even the same code since when you published? Can you remember what version of the code you were on? And now people are asking for the code. You got the sharing problem again, but you may also find a bug in the code. So if you have, you know, if your analysis code is wonderfully successful and you sent it out to more people than you can remember to email, how do you update them about the bug that you've found in the code now? And how do they update you about bugs they've found in it? So the solutions to this are nearly always scripting, which is kind of like a recipe of everything you've done, make files to automate repetitive things, comments and documentation, always comments and documentation, probably more important than version control, but the talk's on version control, and a talk on comments will be very short. It's just me saying comment, document, comment, document. I can do that for 40 minutes and you might remember to do it by the end of it, but I still don't always document my code. So version control and testing of your code. So we're going to focus on version control because it helps with quite a lot of these. So is this version control? That's what it looks like to most people. Sorry, shamelessly stolen from PhD comics. For those of you who can't read this because it's quite small, it's standard example of the postdoc, final.doc, final_rev2, final_rev6 comments, rev8 comments correct. I've seen this. I've seen it too many times. We've all done it. Sometimes we move away from it. Version control can help you with this. It is, think of version control as a nice way to organize things. It's very similar to track changes in Office 365 or Google Docs. It's more powerful, but it's also very much track changes IKEA style. You have to do a lot of it yourself. There's no, it's automatically tracking in the background. You have to remember to run certain commands, do certain things, but it will be better at the end of it. And the other one that's very much like IKEA is there's odd names for things that might not make sense. So at a simplest level, version control is kind of like metadata for development. It tells you what code's been changed. It will tell you when it's been changed. It will have nice comments if you write them, telling you why you made certain changes. And it also lets you know who wrote certain bits of it. So you can find, sorry, I'm going to pick on postdocs here. So you can figure out which postdoc to blame when the code you gave them stops working. Now, I say code, and I'm lazy with my language. I will say code a lot of the time. But you can store just about anything in Git. Whether you should is another question. You can store binary files. So think PDFs, image files like a PNG, JPEGs. Best not to store them in Git. It can handle them, but you won't have all the features of Git, and it ends up taking a snapshot of them. So if you've got an image file that keeps changing, that image file will be stored with every single commit that it changes in. So if that's a 2 meg image, then you're just multiplying it up each time. It works best with any form of text file. So just about anything you can edit in Emacs, VI, or a notepad works really well with it. So text file, Markdown, R Markdown, Tech, R, Python, YAML, you name it. There are many different ways to do version control. You'll see things such as centralized versus decentralized, different providers, whether it's done locally or in the cloud. We're just going to stick with Git. It's the main one used these days in not only software development, but also in academia. And when it comes to the cloud provision of that, I will talk only about GitHub. Again, there are others, and some universities stick with GitLab, but I'm assuming by the sounds of things, it's GitHub here. Yeah. Most of the things are transferable between them. There's nothing too specific. So, can you share from Git? Yes. It was designed to share patches via email, but it's much better if you go to something like GitHub or GitLab. That's when you really get the power to start sharing things. And that has these fancy things like continuous integration, pull requests, issues, private and public repositories, citation, and being findable. As in, you can Google for someone's code and find it, as opposed to it being stuck on their computer and you've got to find the paper and then the academic and then find out which academic holds the code for the paper. Okay. So, where to begin? Git can be a little intimidating. Scratch this point, I never put the link in, but I can send it to anyone who asks. But a few simple commands with Git gets you a long way. And think of it as in modular. You're going to pick out the things you need from it but I'm going to tell you a lot more that you probably won't want all the time. Sorry, this is a comic stolen from XKCD. So it just says, this is Git. It tracks collaborative work on projects through a beautiful distributed graph theory tree model. Cool. How do you use it? No idea. Just memorize these few commands, type them to sync it up. And if you ever get errors, save your work elsewhere, delete the project and download it fresh. Hopefully being taught it and shown the right commands, you won't have to go to that extreme, but it can get confusing like that. So what I'm going to try and do now is focus on the ideas and concepts in Git. I don't want to focus too much on the technical commands, but I'm happy to take questions on that. All it is there are so many things with Git. If I start giving you the technical commands, you're going to lose interest about 10 minutes in, as opposed to 20 minutes. So I want to give you an idea of the concept so that you can hopefully remember, oh, I remember hearing about such and such, and I need to do it this way. And then you can go away and search for that. But it gives you that starting point of knowing where to go, especially when some of the commands and terminology is a little obtuse. So starting out with Git, you just go into the directory where you've got the files, you type Git in it, which just turns it into a Git repository. Then you type Git add and the names of the files, space separated, that you want to add, or you can use wildcard globbing. And then you do git commit -m, open up quotes, and just type a descriptive, useful, thoughtful comment, or something short, because we're all lazy and that's what we end up doing. But the better the comment, the more useful it's going to be to you later on. And that's it. And most of the time, that's all you ever need to know with Git. Yes. Sorry. That's from a terminal on your preferred machine. No, it's just launching the terminal. This is just like any command you would run in the terminal. Yeah. So, yeah. So you do that. And there's a lot of projects where all I ever do is repeat these two commands over and over again. I never go back in the history, but I know it's there. And as I say, you can make some changes and you're basically doing these same things over and over again. Git add, name of the files that you've changed, git commit, or if you're feeling lazy, git commit -am, and you can just do the adding and committing in one line, which can be useful, can be dangerous. So one of the first, I came from a different version control system when I first started, and it never had these two commands. And sometimes it doesn't make sense. But the reason you have this is with Git, the git add allows you to select which files you're bothered about the changes in, because there are times when you're going to change multiple files in your directory, but actually it may be one of them needs changing back to how it was, or you're only interested in the changes in those certain documents. So you do git add to a file and Git will know what has changed in those two files, and it puts it into something called the staging area, because you might not add them all at one time. You know, quite often I've made a change to some code, done a git add, and then thought, oh, actually, no, I really do need to update the documentation. So I go and change the documentation and then add that one. And then when I'm ready, they can just be committed in one. So in this, each commit is essentially the changes made in files, and they're stacked all together in a repository. So the way Git works, and the reason why it's far better with text files than it is binary files, is Git doesn't store snapshots of what your directory looks like some things do. It stores the changes between each snapshot. So each commit, it's the changes. So Git remembers you've added a line here to there. Then you add 3 more lines down there. Most of the time that probably won't bother you, but it is useful to know, because Git stores things as what's changed between things. You can say, actually, I want to remove this commit, and Git knows how to handle that. So it can just go, oh, that line there you wanted deleting. Yeah, we'll just get rid of that commit for you. So that's how you, the simple ideas of how you make those changes and commit them. And then we got git log, and that will tell you all this nice metadata. Yeah, this was from a project of Fortran, which is why they're not my best commit messages, because I was getting frustrated with it. It will give you this long commit ID, which just is a unique ID for your commit, so you can find them. It tells you who the author was, tells you when it was, the date, and it tells you what the commit message was. So in that way, it's kind of like having a logbook for your code. You can go back and hopefully see what was done. So not that interesting, but this one where I had to update the files to remove the trailing one. I think the postdoc I inherited this code from was doing it under the interesting version control. So all the files had underscore some number on the end of them from when they'd updated them. So you just get this nice log that you can scroll through and see what the changes were if you want to go back and look at something. Now, when you're traveling back in time, in a sense, with Git, you can use this command git checkout and then the commit ID. And the commit ID is this long number here. What I failed to say was these are usually pretty unique up until the 6th character. Sorry, after the 6th character. So if I wanted this commit, I could type in that whole long commit ID, or I could just type 8912B8. And that's usually enough, unless you're getting a really long project. And when you check out a previous commit, that means you've got that code back in your working directory then, and you can look around at it, you can rerun that analysis and do anything you want. You will get a warning from Git about a detached head state, and it tells you to look around and be careful what you're doing. Because anything you make changes in there won't be recorded, and you can end up with a few problems. What is the next one? Yeah. So most of the time when you're checking out a previous version, it's to just rerun that code. You can look and don't touch. A word of warning, you will find answers on Stack Overflow of how to undo things you've caused. Git will let you do just about anything, including rewrite the history. This is a bad idea. And let's see how many of you are up to date on TV shows. You rewrite the history and you end up with situations like Mavity. No Doctor Who fans? You should really watch it. The new series is good. He gives Isaac Newton the wrong idea, and suddenly after that they go forward in time, and it's always Mavity. There's no gravity anymore. So just be careful with answers on Stack Overflow. They can change history. So leaping through things here. Right. So when you have your history, you have all these individual commits going along, and each one's different. Put slides in the wrong order, never mind. Git diff is the next most useful command because it will tell you the difference between the code in your current directory and a previous commit. So when you've got that Friday problem and your code worked on Friday and you saw you made a commit, you made 3 commits on Friday, and you don't know what went wrong, diff will show you. Well, first of all, git checkout allows you to go back and figure out which version of your code was working. And then git diff will tell you exactly which lines have changed. So by default, you do git diff and give it the ID of one of these commits. And it will tell you the difference between what is in the directory there and what was in the directory at that point. You'll notice I've used a shortcut here. Head is used to refer to the most up-to-date part here. And you can keep stacking tildes, almost like a minus at the end of head to go backwards. So this is head, head tilde, head tilde tilde, head tilde tilde tilde. If you don't want to use the commit IDs, just if you're only going back a few short ones. So in this case, as I say, git diff head tilde tilde tells you the difference between here and here. You can also ask for the difference between 2 commits. If you figured out it's working here, working here and not working here, no, other way around. Working here, not working here, you can find out exactly what you changed between 2 commits. And you just have to give the 2 versions you want to look between at that point. As I say, I'm trying to give you the concepts here, so don't worry too much about the commands. Quickly going into it, everything in Git is stored as an object, and branches, which I'll get to in a minute, a kind of like a label saying where on a train track almost those commits belong. And when you ask for a specific branch like main, it usually points you to the most recent commit. So if you ask for main, it gives you the most recent commit there. When you make a new commit, head lets Git know where it was previously and what the parent is going to be. So when you put the head in a detached state, it's not pointing at the right place. And that's why it goes, oh, this is my parent now. And you start making changes and suddenly they're not attached to a branch. And if the commits aren't attached to a branch, you'll never find them again. So just be careful in the detached head state. But if you end up there, you search for detached head, it's usually unique enough to only get you answers about Git and how to solve that. So going back to Git diff here, the output of it is usually quite self-explanatory. There's a little bit of stuff at the beginning telling you more about Git, where it's doing a difference between. So in this case, it's the two files it's looking at and how they're stored in Git. I tend to ignore everything in this section. And it's usually here where you're interested. So it has a minus in front of a line to tell you that line was removed. And it has a plus to tell you which line was added. It doesn't come out nicely on the slides, but on most systems, these are highlighted. It will be in red when it's been removed and green when it's been added. And then you can see exactly what's changed on your code. So you've got all those things, and maybe you found you introduced a change to your code, and that's what broke it. And it just happened to be commit number 2. There's two things you can do here. You can just remove that commit altogether. Bad idea because you're rewriting the history. Or you can use a command called git revert, and it will undo a single commit, but it does it in a nice way. So you're here, and you want to get rid of commit 2. So git revert will introduce a new commit that basically undoes that one. So if that added 2 lines and took 1 away, this one will take 2 lines away and add 1 back. And that's why this structure of Git, just working line by line, is really useful. It also means if you're working with text, try and not have too longer lines because it's harder for Git to track stuff down. Most programming languages allow you to put a character at the end of a line to start breaking them up. Definitely works better with Git if you can make your lines as short as possible instead of having one. Yeah, let's pick on my least favorite thing. Pipes in R. They're very nice, but that's one long command. If you make one change in that, then the whole line gets taken out and put back in again. If you stick to traditional programming and do it as small singular steps that are easier to read, personal opinion there, it's a lot easier for Git to handle it. The other thing you can do with Git is you can do git revert and ask it to remove multiple commits in one go. And it can remove multiple commits and take you forward. I've made a typo on that line. Git revert. There should be a flag on the end of there. If you type that command as it is at the minute, it will do commit 5 will undo commit 2, and then commit 6 will undo commit 3. Oh, I'm really annoyed at myself for that. I want to say it's something like -C, but I can't remember it off the top of my head. But that's how you would undo past mistakes. The power of Git comes from branches, I think, and you can avoid having this mess of having to undo problems if you use branches more. And that's like taking parallel history. So actually you want to make a change, you just create a branch and go off. If it doesn't work, it's only a branch, throw it away. And you've not affected any of the rest of it. There are many different styles of how you want to work on this. Some people say everything should be done in a branch, and then you just merge them in as you need to. But it's whatever's going to work for you. Given the size of most software code, in universities, I find most people just happily go along a singular branch. And then if they're going to do something really funky and change the code up a lot, you create a branch. And it's easy to swap between branches on Git. And it does make life a bit easier. So the way you do it is git switch -c if you're creating a new branch, and just the name of your branch. If you're used to using Git already, this command probably looks wrong to you. And that's because I'm going to go with recently. I don't know what recent means. They've swapped from using git checkout to using git switch. They do about the same thing. Git checkout does more. Git switch is safer because it'll control what you're doing, and it's got limited use, so you can't break things too much. So you can create a new branch, you can do your git add, git commits, do everything you want, and then at any point you want, you can just switch back to your main branch or switch back to any other branch, and it will just change all the files in that working directory to reflect whichever branch you're on. So it's great if you're trying to make big changes between things, and also, yeah, just it's a great way to work between things if you're needing to make a lot of changes. So yeah, your workflow will be sort of like git checkout. You make a series of commits, and then you want that back on your main branch where all your main code is. That's when we have the git merge command. Now, again, you can do many different things with Git. I would always advise this -- no fast forward. And I'll explain why in a minute. And then you can delete the branch if you're done with it, or you can leave it around because you might work on it later. So what happens then is your timeline looks like this. It was split, and then all these features get merged back into your code here. If you don't add this no fast forward, if Git is able to, it will remove that branch altogether and make it look like the commits happened sequentially on the main code, which may be annoying for how you want to deal with it, for trying to undo that problem. If you introduce something in this feature that you then want to get rid of the whole feature, it makes it harder to remove it later. Sorry, I think you had a question. I did skip over that. That's called a merge conflict. And compared to other programs I've used, Git's usually quite helpful with that. So when you do merge and you say you've edited that line and that line in both files, and they're completely different, Git looks like it panics, and it basically merges it as best it can, and then tells you to go look around the directory. And all you have to do is you open the file, and you'll go in, and throughout your file, what you'll find is, I think it uses greater than and less than symbols. And you'll do like a series of greater than symbols, the name of the commit ID, the code that was changed, some equal signs, name of the code that was changed in the other version, then no, the opposite one, whatever it didn't do at the top. So you basically get 2 blocks of code, and you get to choose. You can either choose, well, you can do what you want. You don't even have to choose them. You can just delete those lines and put something completely different in if you want. But yes, I need to add that to here because I forgot to mention it. I should have given a nice example to show it. Now, this is where breaking things down into smaller lines is more helpful, because when you get a merge conflict, it can look horrendously big. But the more you've broken your code down into bite-sized chunks, the better Git is at handling it. So that's kind of a whistle-stop tour of what Git can do. And then we get into the sharing stage. So this is when when GitHub comes into play. So ideally, you'll want to be sharing your code at some point, either privately with colleagues or publicly with the world, especially if it's related to a paper. Many of the times I use GitHub actually as a private repository with only me looking at it, because it acts as a free cloud backup. and it means I can access my code from anywhere. The advantage to that is if you're writing analysis code that you'll want to running on a high performance computing system or something like that, it's a lot easier to use GitHub because then you can just sync it up to the cloud and bring it back down again. And I said, there's many options. The main ones are GitHub and GitLab. I think there's also Mercurial, I think it's called. But majority of people I work with use GitHub, so that's what I'm going to focus on. And, you know, you just get a nice web page like this, really. When you go to your individual repositories, it will list you all the files in there. You can browse through them. You can even make these edits on there. So I have a couple of groups I've worked with where, especially they're working with people in the humanities who aren't used to coding in any way, and they've only got markdown files. So they're doing everything. All the commits are being done on GitHub because you can edit the files on there and make those commits. So when you got that code on GitHub, how do you get it down again? Well, that's a process called cloning. And the command here for, this is nothing interesting. This is a teaching repository, git clone, and then you just give the name of the repository that you want. How to find that command? Well, when you go on GitHub to look at the code, you can just click on this button called code, and it will tell you the command you need to type in after git clone. It offers 3 ways of doing it. You really want to be using SSH most of the time. I'm not even convinced HTTPS works anymore. Have you used it or? No, I have a feeling it's broken. They've tried to move away from it, and it's there as a historic thing more than anything. But SSH is the more secure way of doing it anyway. And then once you've got this, you can just act like a normal repository with it. You do your git commits, and all you got to do is remember an extra command of git push. And that says, take all the commits I've made and push them up to the repository. If there's only one of you working on it, it's nice and simple. If there's a couple of you and you've changed it remotely, then you need this extra command called git pull, and you might have to deal with some of these merge conflicts first. But the way it works is if there's changes on GitHub, so your remote repository, you need to pull them down first, deal with them locally, and then push up. Right. I added this one in on the train this morning because I realized I missed it. So it's not the best diagram. So the idea is you have multiple people with repositories, treat these ones as being on their own local machines. And then they have a copy on GitHub. And then there is the central GitHub repository. And I was trying to fit in the terms we need. So we have this, you clone the repository down to you and push it back up again. Now, the way GitHub works is you could work with straight onto this main repository, but there's also a concept of forking, and that's having a copy of a repository on GitHub where you have a personal copy for yourself. So I think if I go back, yeah, so we'll see this one is long_r/change point. That repository is in an ugly state. Best not look at it. But it's a fork of the academics who actually made it. So all this is under my name on GitHub. I can change anything I want, but then I can send those changes back to the academic Rebecca who originally created ChangePoint and make those modifications. So there are 2 well, actually last time I looked at it, there's probably about 30 repositories with ChangePoint on GitHub. One of them belongs to Rebecca and all the others are forks where people have made modifications to it for one reason or another. It may be to send changes back to the original creator, or it's that you want changes just for yourself and you're not confident about sharing them with other people. But you can fork repositories. It's not a problem. It's like your own local copy on GitHub. And there's this whole chain of ways that you can send things backwards and forwards, including forking, which is where you get your copy, and then the awkwardly named pull request when you want to push your changes to someone's repository. So, forking. You get the repository page that you're on. You'll see a little button called fork, and you can click on it. Here, I happen to have already forked it. but you could create a new fork as well. So this is a software carpentry's course on how to use Git, which is why it's got so many forks on it at the minute. And it's a pretty nice, easy to use layout. Sorry, banned word there, shouldn't say easy. It's a nice to use layout that can be intuitive sometimes. So pull request, that's when you take your fork and you want to send the changes back to the original creator. So this is an example on change point again, actually. And this is when it gets confusing, because you'll notice it tells me that my current branch is 98 commits ahead, but 32 commits behind, which does not make any logical sense, but it means I have added 98 commits to this repository since I've changed it. And the original repository, Archilic change point, has added 32 commits since I last synchronized the two between. So that means there's going to be a lot of work on my part to synchronize these two up. But actually, the reason this one's still open is it did cause a lot of work because I edited a lot of conflicting files, but normally it's not too bad. It's just a case of pull down, make a couple of changes, done. So that's how you sort of send these changes back. And pull request does have an odd name because it's your request to the creator to pull your changes into their repository. You can't forcibly push these in. It's opening a dialogue, and it's actually a really nice feature because it can be a whole conversation. You send that request to someone, they can look at it, they can suggest, actually, I do like what you've done, but I want you to make a few changes first. You can keep making those changes before it finally goes through. And again, modular, depending on the size of the project, you can make it so that when someone creates a pull request, a series of tests automatically run on it to check what state that code is in and whether it's acceptable. It can even, I've seen some where it runs tests and then it requires two different people to review the code physically before you can even click on that button to say, merge this pull request in. But it's a great way of doing things. The way I've usually seen this work and the whole forking pull request system is you have something that you're working on with your postdocs and PhD students. Your postdocs and PhD students fork your repository. They make their changes that they need to do. And then you can check what they've done is sane before you merge it into that public repository and then update it on CRAN, for instance. So it adds that extra level of safety in to check things, but actually puts proper reviewing practices into code instead of just someone emailing you going, I've updated the code now. And it may or may not be broken or might not do what you want. The other thing you get with GitHub then is there's a tab, I guess, called issues. And you just create a new issue. Click on new issue, you type in what your problem is. That might be, there's lots of tags you can use with this as well. So quite often I see it used with academics where they've got a load of ideas of changes they want to make to something. So they just open new issues, one for each change, as almost a to-do list sat there. It's also a great way to farm work out to your PhD students and postdocs. Create issues, tag their username in it, and ask them to sort it out by next week for you. But it's also where people using your software or using your code or your documentation can open an issue when they've had a problem with it. Instead of trying to find who to email, they can just open an issue. Hopefully they open it with and type in there a solution to the problem they're having that needs fixing in your code, but it's also a way of tracking any problems and usage. It's quite powerful. Again, I find it very intuitive. If you click on new issue, it gives you a bit of information of what to do. And again, if you're scaling up to a larger thing, perhaps again, talking about CRAN, if your package on CRAN is becoming popular, you can create templates here so that people have to fill the information in a certain way. And the other thing you can do with GitHub is a README. So this is taken from MetaWards, which is a really nicely written piece of academic software. The README is the first thing people will see if they go to your code on GitHub or if they go to your GitHub repository. So it's kind of your advertising page. You don't have to create a web page for your nice thing that you're sharing. It's there. You can do a lot with this. You know, this one tells you that currently the software isn't building the way it's meant to. It tells you how many downloads it's had. It links to the JOS paper. It gives you the DIY for the software. It can contain a lot of information. I recommend that this is where you give the instructions of how to, the simplest use case for your, if it's software, sorry, the simplest use case for it should be written in there. I would even go so far to say that, especially in data science and maths and stats, the people finding your software may not be familiar with the program you're using. So a quick link to how to install R, or how to, not you writing the instructions, just a link reminding them it needs R. This is where you go to find out how to install it. I mean, it might be that I'm lazy, but if I get to a GitHub repository and I can't get the software up and running in 10 minutes, I'm going to find a different, I'm going to spend half an hour finding a different piece of software instead. But, you know, aim to have it so they can be up and running as quickly as possible. Give as much information as you can to get that first thing running with it. And the reason you want the README is taken from Overly Honest Methods on Twitter. You know, it's code shared. You can download our code from URLs supplied, but good luck downloading the only postdoc who can get it to run. Try not to recreate this, you know, have a nice read. First of all, your code should be written in a way that it's nice and runnable. That's a separate issue. But the README should at least get them there. The other bit I want to add, which is a newish thing coming in, is citation file format, which I'm assuming most people haven't heard of. It's a file you can put in a repository. It has, I think it's a YAML structure to it. But it tells you, you can contain all the information you want there, who the authors are, how to cite the software, and it even has like a little cite this repository button. You can click on it and it can give you the APA or the BibTeX citation format for it. So there's lots of information on that. It's written by some chaps at Manchester and the RSE team in Germany. It's quite powerful, but it gets that next step of how do you cite software. And you can put all the things in there you want, because there's often the question of, do you cite the software or do you cite the paper? You can tell people which one's more important to you and which one to cite there. It may be for your field, citing the paper is more important than the software. But at some point, hopefully we'll get to the point where the software is put on equal weighting. And I'm going to quickly run over this, but just to let you know, continuous integration is a form of automation you can get with GitHub. So this is where you can use something called GitHub Actions. I'm afraid I don't know what they're called under GitLab, but there you can write tests. So you can have it run some tests on your code, and every time you push those changes up to GitHub, it will rerun these tests. So you can see how I made some bad changes in one go because it told me that my tests failed until I remembered I'd forgotten a dependency somewhere in it. But it's a great feature, especially if you want to show people that your code is reliable and reproducible. But also just as a quick check to make sure in your own sanity that everything's working the way you thought it was. You can't see much, but that's a quick line. All this one does is run the tests on the Python file. That is 26 lines long with a few bits of spacing in there. And most of this is all the similar. You see, it runs on 4 different versions of Python for me when it does this test. So it checks the most up-to-date versions. It then clones the repository. So it gets that code down and it runs all the tests I've written to go on it. So each time I upload it, the added feature of this is I only have Python 3.9 on my machine most of the time. but I now know it works in 3.7, 3.8, and 3.10 because of this. If you're doing this in R, I think there's a package that will write that file for you at the most simplest form. So it's a nice way to do it. So it's, again, something to go away and search about if you're interested. And just to review, that typical workflow, we have our working directory, the directory you'd be looking at on your computer. You do your git add to put things in the staging area. When you're happy, you commit them. When you've done all your work for the day, you push them. And when you're on a different machine or you want to do them, you do git clone or git pull to get it back down again. And you can do git checkout to get whatever version of that code is you want there. Yeah, we used to have a nice sign up in the office I used to work in that just said, in the event of fire, git commit, git push, get out. I work with the carpentries. They have free lessons that actually you can just teach from directly if you want. You just can't call it a carpentries lesson when you do it. You can say you are teaching from the carpentries resource, but don't say you're teaching a carpentries course. But they have lots of lessons on things like this. Usually find the most useful ones are under software carpentry or data carpentry, but they have a course on how to use the command line, how to use git is the main one. I think there's one called intermediate software engineering, which tends to conclude some of the more advanced git features. They don't currently have anything for GitHub. Yeah, final note, it's a tool, it's not magic. So Git and GitHub are very powerful, but they're only as good as its use. I don't use all the features of Git and GitHub in every piece of software I write. And it depends on the project, how well I use it. You know, I'll admit a lot of my commit messages do tend to look like this towards the end, especially if it's the Fortran program I'm fighting with at the minute, and it doesn't seem to work no matter what I do. But at least it's in GitHub. At least there is something there that I can search through. Cool. And that's it. Sorry, taking longer than I thought. But...
Any
Thanks. Thanks. Do you have any recommendation for when to commit and push? I mean, other than some gut feeling that reach.
Little and often is always the advice. I tend to try and make sure if I'm adding a new function to my code, it commits to that point. Because anything more than that tends to get complicated. So it's, and anything less than that, it depends how you know, I try and say it's the Python advice that a function should at least fit on the screen without having to scroll. So the functions are you're going to need to commit more often. Yeah, it is very complicated, but as often as you can, it's useful. But I know I'll say that, and I'll probably spend the morning doing lots of little commits, and then somewhere around 3 o'clock, we're like, I'm going to commits and day. So, but as long as it's committed at some point, it will make you more likely to make a start.
Yeah, questions?
That's a lot to you that you share code with collaborators, a nice way to keep stuff, and then they kind of corrupt it by working on Excel or doing manual changes that cannot be tried. I mean, that happened with Android.
There you go. It's happening from time to time, and there is a very powerful command called git reset. It's almost it can be used nicely, but it's almost a nuclear option. You can really type the end people if you want.
If what they do is correct, just not capable.
Oh, okay. It's not. Yeah, there's an easy way to sort of take a little break down steps again. But this is why I encourage branching and pull requests. What I didn't say pull requests is, if you encourage people to afford the pull request, they don't have to undo all of their individual commits. They have to do them all and realise that post office and some code in a really awful way that broke things much later on. You can just remove the singular pull request. And it's a lot easier to extract it from the code, and then you can sort out their code, and then you can pull request and put it back in again. But yeah, Git reset will allow you to do a lot of things. So you can word advice, which is lessons learned. Be careful what you're adding. Don't just do Git at start. Everything in that. You don't want to upload private SSH key for a server. Even if you delete it, it still stays on GitHub for a while and then backups. So you don't have to end up sending them email asking them to post backups early. You don't put it once.
I want to do something else, but I know, but I'm really curious as to what you said. I thought because of the way the commits work, lots of the stuff just stays in, still be recovered unless you do rather extreme magic.
Yes, yes. So,
And therefore,
it stays in there. You deleted it, but it's still hidden within the repository. You can prove. I think it's getting proven to get rid of things like that. We just changed. I just changed the SSH.
Yeah.
But it's be aware of deleting something from Git or deleting it from GitHub doesn't necessarily be this.
so what I actually want to ask before we kind of got there is, you mentioned that this is a good way of being able to push bug fixes out towards out to your collaborators.
Yes.
And of course that is nominally true, but I kind of wanted to ask more about the more technical aspects of this. So let's say tomorrow we have released a package and we discover that it's doing entirely the wrong thing. How would you recommend going about that? Not that this has happened, or indeed I know it's happened, just to be really clear, but it was kind of an interesting scenario that I was curious as to what you would recommend.
It's not easy on small to medium scale projects. It's and even on larger ones these days, I don't really think people pay attention to what they need for a project in the same way they once did. The part of the information overload we have, you just don't sign up to these things. So you just have to trust they're checking it. Now it does mean that if they have thoughts they're working on, when they get whether they want to sync that forward or not, GitHub will tell them that they are solely commits behind, and it's up to them to see what it's doing. But at least if it's in there, you've done your due diligence, you've pushed your changes down, you made it public, and maybe you'll rebuild or you've changed this. That's kind of the best. But it does also mean that if you're using software that you want, then you need to check every so often. There may be changes, there may be lots, but it's the same. Even if you're using something on high or crap, it's not something we do very often. But yeah, I think that's the best one.
Any more questions? I'm not hungry. Thank you, Rob, again. It will be having like show say, so if you do have anything you want to have chat, Rob, please speak to your.
You can also drop me an email.